You can use object-oriented programming techniques in a limited way when working with generics, but to do so requires that you use some new syntax. The extends keyword in this context limits which classes can be used in the declaration to those that are a subclass of number. The integer class is a subclass of number, so it can be used. Also, the double class is a subclass of number, so it can be used. But that's not all extends means in this context. In this example, the type isn't limited to a subclass. The type must implement the interface named eventListener. The syntax of the code between the less than and greater than signs of the generic definition is not the same as it is in the rest of Java. With the addition of generics, Java no longer has a context-free grammar. Keywords and operators have different meanings depending on where they are used. In this context, the keyword extends means that the chosen class is limited to either a subclass of the named class or that it implements the named interface. In this example, the classes JTable and UndoManager can be both used because they both implement the eventListener interface. You can include both class names and interface names as the limiting requirements on the same type variable. In this example, the type used must be both a subclass of image and implement the interface transparency. The buffered image class is both of these things, so it can be used. You can have as many interfaces as you wish in the list. Including more than one class in the list would be pointless because of the single inheritance of Java. The ampersand character has a different meaning in this context than it does in normal Java expressions. Normally, a comma is used as the separator in lists, but in this context, the ANDing operator is used instead. If you want to use inheritance to construct your objects, you might want to avoid generics. They don't work as you might expect them to. Take this declaration. You might wonder how it falls in the class hierarchy of superclasses and subclasses. Well, it doesn't. It's very much of a standalone item. The stash class has a superclass. You can define it as extending another class, or it will default to object being its superclass, but the number class hierarchy cannot come into play here. You might think this is a subclass, but it's not. Remember the earlier lesson about discarded information? The very thing that you will need to inherit the information about the number is the very thing that's thrown away. There is no way to build a subclass of stash either, because no stash class definition exists without the generic part being added to it. To create a superclass and subclass relationship, you could create the superclass this way. Then you could create a subclass to hold whatever types of number objects you like. It would only be a matter of overriding a few functions to do the more stringent type checking. You could easily make a class for any kind of number. They could both be made to be subclasses easily enough, and the type checking would be done at compile time, so you would have all the advantages that you get from generics. One more lesson on generics coming up: generic wildcards and the nesting of generic names.